Hello, and welcome to a little video about the exponents wrap up. What this means is we're going to put everything we've learned together. Now, I know these problems look a little crazy, but they're not. We'll break it down. I'll show you a nice way of doing them. There are multiple ways of reducing these problems, okay? So I'm going to show you the way I think through it and the way my brain kind of catches on. You might come up with a different way of doing it, but if we come to this, as long as we come to the same answer, we're good. So, um, let's start by taking a look at letter A. What I look for first here is, are there parentheses? Because if there are parentheses, we've got to take care of them first. If not, what I like to do is break up my problem into groups. I'm going to create several different fractions, but I'm going to organize them based on variable and constant. Here's what I mean by that. And this is absolutely allowed according to the rules of multiplication, I promise. So, first let's look at the constants. Constants are numbers without they're just our regular big numbers. So we've got a 4, a 2, a 5, and a 2. I'm going to create just a single fraction that has 4 times 5 on top and 2 times 2 on the bottom. I'm going to create another fraction with only x's. In the first fraction, I've got x to the power of 3. And on the bottom of the first fraction, I've got x, which is x to the power of 1. In the second fraction, I had x to the power of 1 on top and no other x's on the bottom. I'm going to create one last fraction that has y's. My first fraction has, or in the original problem, has y to the third on top and y to the first on the bottom. The second original fraction has y to the second on top and y to the first on the bottom. To me, this is so much more organized and way easier to reduce. Let's start with just doing all the multiplication on the numerators and denominators. And then we'll divide if we need to. 4 times 5 is 20, 2 times 2 is 4. When we multiply exponents with we multiply bases that are the same, we add their exponents. So, for the top of the x's, I end up with x to the 4th. And we're still x to the 1st on the bottom. Let's add the exponents on top of the y's and the bottom. For the top, we have 3 plus 2, which gives us 5. And then we have 1 plus 1, which gives us 2. Lastly, let's divide. 20 divided by 4 is 5. When we divide the same base with two different exponents, we subtract their powers. 4 minus 1 is 3. For the y's, we do the same thing. 5 minus 2 is 3. I guess we could take it. No, we're good. This is it. That's as far as we can go. Let's take a look at B, because this one has parentheses and negatives. Ooh. We'll still do it the same way, but we do need to take care of the parentheses first. Order of operations says so. Remember, I got 1's for the 2 and the x, and I'm going to multiply the powers by that power. The first fraction remains the same. The second one, we end up with 2 to the power of negative 2, x to the power of negative 2, and y to the power of negative 6. The bottom stays the same. All right. Well, I've got negative exponents here, but first let's rearrange things, and then we'll see where we go from there. Then we can flip or add or subtract, but first let's rearrange. Starting with the constants. I have 5, and I have 2 to the power of negative 2. There's nothing on the bottom of the fraction, so I'll just give it a 1. Okay, now let's do the x's. I got this one, and this one. Alright, so I got x to the negative third times x to the negative second on top, and x to the fifth times x to the first on the bottom. And now let's do the y's. So we've got y to the third times y to the negative sixth on top, y to the negative first times y to the first on the bottom. Okay. Let's go through it one by one. Let's see if we can do some multiplying. In that constant fraction, I get 5 times 2 to the negative second, which we really do need to bring 2 to the negative 2 on the bottom to make it 2 squared. Because we can't add it with anything. We can't do anything else to it. Right, so that's the only thing I could do there in this one step. For the x's, since we're multiplying on top and bottom, let's add the exponents. On top, we get x to the negative fifth. On the bottom, we get x to the power of 6. For the y's, we get y to the power of negative 3 and y to the power of 0. Cool. Let's see where we can go from here. Well, I can rewrite 2 squared as 4. So I can rewrite this as 5 over 4. Next, we're going to subtract the x's, or the exponents for the x's. Negative 5 minus 6 is negative 11. We'll do the same for the y's. Negative 3 minus 0 is negative 3. Don't forget what we've got to do for those negative exponents for our last step. We're going to flip them to the bottom of the fraction. Okay, that's our final answer. You know what, I guess let's space it out a little bit more. I was spacing it, let's do it like this first. Let's make it 1 over x to the 11th, 1 over y to the 3rd, and then we'll bring it all together. Gorgeous. Alright, that was A and B. Let's do C and D. Ooh, okay. C has everything to the 4th here, so we got to do something with that first. The original first fraction is going to stay exactly as is. We are going to multiply all the powers in this quotient by 4. We get x to the power of 12, y to the power of 8, 8 to the power of 4, x to the power of 4, y to the power of 4. Wow. Alright, let's do my organization method. Let's start with the constants. Zoom in. Oh, thank you. We got 16 in the first fraction and 8 to the 4th in the second. Excuse me. Now let's organize the x's. In the first fraction, I got x to the 5th and x to the 7th. In the second fraction, I've got x to the 12th and x to the 4th. Okay. Let's do our y's. Y to the 8th and y to the 4th from the first fraction. And also y to the 8th and y to the 4th on the second. Nice. I kind of like how that matches. Alright, let's simplify. Oof, Okay, we gotta find out what 8 to the 4th is. 'Cause I don't remember that off the top of my head, excuse me, while I calculate that. That's 4,096. Let's multiply the x's on top and bottom of the fraction, which means we're going to add the exponents. So we get x to the 17th on top and x to the 11th on the bottom times y to the 16th over y to the 8th. Okay, now let's do some division. Let's see if we can simplify 16 over 4,096. We absolutely can. That becomes 1 over 256. When we divide two bases with different exponents, but the bases are the same, we can subtract the exponents. 17 minus 11 is 6. For the y's, 16 minus 8 is 8. Let's organize this all into a single fraction. X to the 6th and y to the 8th are going to go up top because they're whole numbers, and all whole numbers are technically fractions over 1. 256 goes on the bottom. All right, let's do one more. And if we were in class, I'd send you off to do some work. In letter D, once again, we have a power of a quotient. So I am going to multiply all the powers by -2 before I reorganize them. Keep the first original fraction the same. For the top of the second fraction, I end up with 2 to the power of -2, x to the power of -2, and y to the power of -4. On the bottom, I get 3 to the power of -2, x to the power of -2, and y to the power of -2. Okay, now we organize. Let's start with the constants. We got 4 and 2 in the first fraction. And we'll take care of those negatives, all good. 2 to the -2nd and 3 to the -2nd. Don't worry, negatives, we'll take care of these. All right, next come the x's. The first fraction has x to the first and x to the -1st. The second fraction has x to the -2 on top and bottom. And now let's organize those y's. For the first fraction, I have y to the first on top and y to the -3rd on the bottom. For the second fraction, I have y to the -4th on top, y to the -2nd on the bottom. All right, let's see what we can do. With the constants, I really do just need to flip those two, the 2 to the -2nd and 3 to the -2nd. That's the first thing I really do have to do before I do any multiplying or simplifying. For the x's and y's, I can add the exponents on top and on bottom, because if we multiply two of the same bases, we can add their exponents. Okay, so we got 1 plus -2, that's -1. And on the bottom, -1 plus -2 is -3. Let's do the same for the y's. On top, 1 plus -4 is -3. On the bottom, -3 plus -2 is -5. Okay. Now let's start reducing. Let's figuring things out. Let's divide. For the first fraction, I can finally multiply. 4 times 3 to the power of 2 is 36. 2 times 2 to the power of 2 is 8. For the x's, when I'm dividing the same base, I can subtract their exponents. -1 minus -3 is positive 2. Y, we're going to do the same thing. -3 minus -5 is positive 2. Before I write that equals, let's see if we can reduce the fraction. Can we do 36 divided by 8? That would be a yes. Do you know what it reduces to? We're going to have a 4 on the bottom, I think. Hold on. And yes, and an 8. Wait, hold on. I'm having a brain fart moment. Come on, Gumin. What's going on? You divide both by 4. Yeah, duh. And you get 2 on the bottom and 9 on top. Ugh. Oh, Gumin. All right, x squared and y squared, they're whole. So I'll put them up top. Let's put the 2 right here. There you go. Fantastic. I know those were long problems, but if you work on them slowly, you'll be fine. I don't know how many I plan on requiring you to do during class, but I'll let you know. Otherwise, have a wonderful rest of whatever day it is for you. Bye!